Yeah, comes on everyone. Let's see. So we got a capacitor, the battery. Case 1, battery is removed. Case 2, battery is present. Now in both the cases, a dielectric slab K is introduced in between. Basically, you filled up the space between with a dielectric. Same thing. We have done this before. The various at the distance between the plates is doubled. So Q new capacitance, new voltage, new field, force between plates, energy stored, and energy density. Case 1, case 2. So you should tell me whether it becomes, K times, 1 by K times, remains same, say so. So here options will be in terms of K. Let's get this. Right. Again, what is the idea there? If you remove the battery, charge will remain constant. If you keep the battery, voltage will remain constant. Okay. Get them. I'll give you a minute. I'll show you both. Let's see. In the first case, charge remains constant. So this will remain CV. Q nu. So first thing, the capacitance becomes Kc. Charge remains Q. The voltage will become 1 by K times because it is Q by K. Q by C. Field is nothing but V by D. Potential difference became 1 by K, and so this also becomes 1 by K. And I can write the potential will be V by K. Field also becomes 1 by K times. Force is simply Q square by 2A epsilon. Now be careful, just force between the plates. So the dielectric won't affect here anything. So this will remain same. The K is same, Q same. So energy you can write Q square by 2C. C became 1 by K. So this is K times.
So should we not get K in the denominator of force?
This is 1 by K times.
Uh,
Why, Ray? Don't
epsilon
don't
not
tell me your
enough.
feelings, na. Give me a reason.
Epsilon
God,
not enough. It's because K epsilon.
force between plates.
Oh, it's between plates. Okay, okay. Look.
Even if it
But
is force on the plates, it won't matter, God. The slab is in the middle. This minus sigma plus sigma won't affect net force is zero on the plate.
okay, okay. हाँ सर।
That 1 by epsilon कब आएगा? If the entire charges are placed in a medium, the medium should be till infinity.
यस
हम्म
सर, समझा समझा।
हम्म ये होगा, यहाँ पे epsilon becomes 1 by k times and E becomes 1 by k. So this is 1 by k. Clear?
सो
हाँ,
सर वो जो फोर्स वाला था, लाइक कांट वी राइट फोर्स एज चार्ज इनटू इलेक्ट्रिक फील्ड ऑफ वन प्लेट?
लिखो ना।
सो तो लाइक इलेक्ट्रिक फील्ड तो चेंज हो रहा है ना 1/k, तो लाइक चार्ज सेम है, इलेक्ट्रिक फील्ड 1/k टाइम्स हो गया, तो Q इंटू E/k,
Q into,
मतलब वही वन बाई
okay,
के टाइम्स हो गया ना इलेक्ट्रिक फील्ड
why?
चार्ज। सॉरी सर।
Understand what you're saying ना रे? Why 1 by k? Who told you it became 1 by k?
सर क्योंकि फील्ड हो गया ना, फील्ड 1/k टाइम्स हो गया ना।
प्रूव करके दिखाओ मुझे. Is the field 1 by k on the plate?
बिटवीन द प्लेट्स।
But what did you say? You said field
ओह,
on the plate.
ओह ओके, ठीक है ठीक है ठीक है ठीक है।
So case 2, what happens? Case 2, voltage remains same. People are getting confused now. This is plus Q, this is minus Q. This is minus Q induced. This is plus Q induced. These two, right? If you see, net force on the plate is 0 due to these two. If minus Q induced will attract and Q induced will repel. So the dielectric slab will not exert any force on the plates. Are you getting it? So the only thing that is left is this minus Q will attract this plus Q. That is the only thing that is left. Clear? The field becomes 1 by K where? Inside the dielectric. That is, if the field outside is Z, then it is E by K there. Don't use this field on this plate. Now what? This becomes Kc. This becomes, this will remain V. This will become Kq. Field will be, potential is same, distance is same. This will remain same. Now here will people think, sir, what happened here? Abhi dekho, yahan pe what happens now? If you write in terms of charge, the charge became kq times, and but that niche epsilon also became k times, so they'll cancel off. The field will remain same. Field between the plates. Force here would be k square. Again, that epsilon won't affect. This is force between the plates. And even if I say force on a plate, it won't matter because you can't take the field inside the slab on the plate. So this will be k square. Think about that. Still confused? Let me know. Because if you're saying force between these two, why do I care about these two guys? So even if I care about them, they still cancel out. What about energy? Use half CV square. This becomes K times. Energy density. Field remains same. This will become K times.
सर won't it be k cube times?
K.
Half epsilon naught e square. Epsilon naught becomes k times. E square will be k square times.
Field is same record. Which one is this?
So
So kya? Is it me who is not well or you're also not well?
in the formula it fits ना मतलब E square है and epsilon naught है. But it's the same thing for the previous one also ना.
So E तो कितना हो गया गॉड?
E k times हो गया ना.
ये सेम है रे. ये एनर्जी नहीं है गॉड.
Oh, okay. Sorry. I'm sorry.
Do and of this thing. Clear. Don't go far. Next thing. Let's see one more. So we have a parallel plate. This is K. This is 2K. It's like a sandwich, the diagonal part. Distance between them is D. This is a side A, the square plate. Find C equivalent. So battery is connected between these two terminals. This is a HCV question. You getting the diagram how it is? The diagonal part is a K and the other is 2K. How do we start this? See, a distance x from here. take a small piece dx. So this lower part would be k. This upper part would be 2k. Let this angle be theta. This is d, so we know tan theta is equal to d by a. Now, if you look at these two pieces here, this would be the area. It's a very thin piece. You can almost ignore this. This would be x tan theta. This would be d minus x tan theta. And this top part would be the area. Area would be a into dx. This was a, and this thickness was dx. So you can treat this as two capacitors, DC2 and DC1. You're getting? And both of them are in series. And these slabs are in parallel because all have same potential difference. Is that making sense? So DC1 will be how much? So DC1 will be area, which is ADX into K epsilon by the distance between them, x tan theta. A epsilon by D. A का place में ADX, epsilon का place में K epsilon, and D का place में x tan theta. DC2 will be, again, the area is same, ADX to K epsilon, the distance would be D minus x tan theta. And both of them are in series. So 1 by DC is 1 by DC1 by 1 by DC2. So this would be d minus x tan theta by 2 a k epsilon. No, I wrote reverse. This is d minus, no, right only. D minus x tan theta by 2 a k epsilon dx. This would be x tan theta by a k epsilon dx. This is 1 by dc. You can take out the denominator thing, and this thing adds out to b. Add 2 there, we get d plus x tan theta by 2 a k epsilon dx. Now all these pieces are in parallel. So I can add dc ka integral I have to do. Now all these pieces which we got, remember it's a very thin strips, all in parallel. We know then in parallel it is C1 plus C2 plus so on. So equivalent would be DC. So you have to be careful. If they're in series, so then you have to integrate 1 by DC ka equivalent. So this would be 2a epsilon k dx d plus x tan theta. Limits of x will go from 0 to a. This would be 1 by tan theta ln d plus x tan theta. And we know tan theta is equal to d by a. This will be 2a square k by d. This is ln d. Tan theta is d by a, so this is ln 2. Clear? Check your steps. The main idea is this. You have to take a thin slice there and treat the upper one and the lower one as two capacitors. Both are in series because they have the same charge flow, and all these pieces are in parallel because they have the same potential difference. Next one.
So here the capacitor is a square or what?
Capacitor is a plate, square plate ना record.
Oh, sorry.
क्यों फर्क पड़ेगा क्या?
Because
If
you
it is
took
not
A
a
as the
square
length
plate.
also.
हाँ बस वो भी आ जाएगा बस.
हाँ.
Then in the end में it will be like AB, A square का
Yeah,
place में
I was
AB
getting
कुछ
one
आएगा.
extra variable in the answer. That's
वो square plate लिया था. Clear everyone? Got the process? Let's see next one.
Sir, we can do like this. We can apply. Can we apply the formula directly here?
Which one? Energy is half CV square, that formula. Or momentum is M into V. F is 6 pi r eta V. Which formula?
And that one, that
Which
D
one?
equivalent like D upon
V terminal velocity is 2 by 9.
epsilon
VC
V by
equivalent.
D minus T1
वो
minus
किसके
T2.
लिए था God? वो किसके लिए था? You derived that for what conditions? What scenario? That is this one, right? Does this and that look any resemblance?
We can take
This.
strips that
What
way.
will you take? Strips, how will you take like this? इसमें God element ऐसा दिया था.
Oh, I took it perpendicular.
हाँ.
Well, that is not allowed.
Yeah.
And
There's
in
a
the that's why I didn't get the D plus x tan theta. I just got that
mm,
x tan theta.
there's a difference between a rhinoceros and a unicorn, even though both have a single horn. इतना difference है दोनों problem के बीच में. When some kids ask you, na, is there a unicorn? I think it must be a rhinoceros only, it's a unicorn which has become little fat. Isn't it? A rhinoceros is a unicorn which is overweight. So we have a square plate here. Yeah, I hate drawing the square plates. Okay, let this be a plate here. We have a battery V here. You are introducing a dielectric slab. Okay. So this is gone X inside. The length of the dielectric slab is also the distance between the plates is D. This is a dielectric slab of mass M. And length L. These square plates also, right? I think let's not take square plates. So let this be L and let this be B. देखते हैं कुछ फर्क पड़ेगा. This is how the view actually looking like. Battery is between these two terminals. Getting it? It's the same thing. I'm just drawing one more there. So it's a rectangular plates. This side is L and that side is B. ठीक है. So find the capacitance as function of x. So the x amount of slab is gone inside. Find capacitance, energy, and force as function of x. X is the distance by which the slab has gone inside. X is the length of the slab between the plates. When it goes exactly completely inside, it fits properly. That is 1. And find the time period of oscillation. By just introducing it. Find time period of oscillations. Let's get this. First, let's find the capacitance. I hope you're getting it, man. I just want to help with the diagram. This is how it looks. So this part is filled with slab, basically. But I'm just asking for the capacitance. So this would be x, and this would be L minus x. This would be B, and this is T. This is easy. Both will be in parallel. Try. I'll give you a minute or two. So this can be treated as two capacitors. Both are in parallel. So this thing is like so this thing area would be B x k epsilon by d. This guy would be B L minus x epsilon by d. Both are in parallel, so you can directly add them up. B epsilon by d common will come out. You end up with L minus x plus kx. What is the energy? The energy U would be half C equivalent into V square. So half P epsilon V square by d L plus x into k minus 1. How do we get force? Minus du by dx. That is the only way you can get force in this thing. Because the field is non-uniform and all. If you see why the reason why we are getting force is because of this. The slab which is introduced here, if you remember, now see, these charges are non-uniform. Unless this thing goes completely inside, you can't tell anything about this thing. So if you look at the field lines here, the field lines are actually like this. The fringe fields outside the fields are like this. So there's a force of attraction between them. So these charges get attracted like this. These positive charges get attracted towards negative like this. This results in a force into the slab. The induced charges and these, they get attracted at an angle. And this force will be inside. So that force is given by minus du by dx. You get minus b epsilon v square by 2d into k minus 1. And if you see, interestingly, this is constant. This is a constant force and negative indicates attraction. So if you just introduce a slab and leave it, it will just go off. Pretty useful results, right? Especially the force part. If it is a square plate, you will take A epsilon V square. V is the voltage of the battery.
So, but
You
why
have
is
a look at
charge
this.
getting induced on the thing outside the plate?
Okay. So you mean to say, if I keep something here and if I put plus Q, where should the charge be induced according
No,
to you?
like we are considering parallel plate capacitors which are infinite, right? So like the field will only be in between them, right?
So if it is infinite, how is there something outside here? You consider them infinite for the field between the plates. Now, once you go outside the plate, it is messed up outside.
Okay.
That is only for convenience you trade between here, right? You don't basically ignore the edges. That's what you're saying. Now, the
So
slab is only
basically,
outside. You can't
okay.
ignore here. And we can't find the force, using that E into Q because of the same reason. The field is non-uniform. Charges are non-uniform.
Got it.
Now, since we got the force here, now what has happened? Now, this is a simple question. They'll ask, like, what is the motion current? People think SHM. Be careful. Here, F is constant. So this is F. We get force is equal to mass into acceleration. We get A is constant. This is not SHM. This length is L. So T0, it will be here. So how long will it take for this to go inside? So after some time, this slab will completely go inside. The best part is this, no matter the value of X, if the slab is partially entered or completely entered, the force is same. We can use the equation S is ut plus half AT square, since the acceleration is constant. U is 0, L is equal to half AT square. So from here we get the time root over 12 by A. This is the time just to enter inside. So if you look at the whole process, this is how it looks. The slab is released from here. It goes inside. So at this position here, speed is maximum. Force is 0. So it will come outside. Again, at this point, force is there, but velocity is 0, reached extreme. Then again, you will go inside. But this time the speed is maximum. Only when you're completely entered inside, right? By symmetry, you can say it becomes 0 again, and then this thing comes out. So this is T0. This would be T by 4. Let's call it capital T actually. This will be capital T, T by 2T, 3T, and 4T. Therefore, time period will be 4 times of this. Do have a look at this. A is the acceleration here. And what kind of motion is this? This is periodic motion. This is not SHM, this is not oscillatory motion. F is constant. For SHM, A should be proportional to minus X. Here it doesn't depend on X, only the force part. It's one good question, matlab.
So if they ask us like the point of stable equilibrium will be like the middle of the plate, right?
Undefined error god.
Why? We'll
Stable
come back now
equilibrium.
if you displace it from there.
You can say that problem. You can say that. It's not. Yeah, it comes back here. It comes back here. It is stable equilibrium. Both weird. Matlab, this function only looks pretty weird.
Achha, so like if we do the derivative and all,
It is it is like this point is equilibrium. Suddenly on both the side force goes up. It's a discontinuity.
Oh, right, yeah.
Continuous function नहीं था वो.
Understood. But
Because
like
if
in the
you push
exam,
that
if it
side,
comes,
yeah, but it is stable equilibrium only, because if you displace it, it always comes back to that position.
okay.
And we
Clear,
comment
everyone? Comment on the
the change in properties with respect to time,
change in property.
and change in energy and change in charge flowing with respect
With
to time.
respect to time, निकाल सकते हैं ना. X is equal to half AT square, तो you will get it. अब x का वैल्यू आ गया ना. Substitute half AT square, half into acceleration times square. There you will get everything.
And how
Right?
do we get the change in charge? Change in charge and change in energy function.
Differentiate करो ना God. Just differentiate it. क्या doubt है? X is equal to half AT square. There you got energy in terms of time. Just differentiate it.
Okay.
Ne? Right. So you got acceleration, right? You can find the position as function of time, how much it has gone inside. Now the same thing, right? You could have played like this also. We'll just do this normal instead of a question. So if you take the two parallel plates and if you connect a battery, and they'll ask like this, this thing is just placed on top of a liquid. So what will happen now? This liquid will act like a dielectric slab. This is rho and K. The liquid rises. Why is this rising here? Because this force of attraction should be equal to mg. So force of attraction would be, this thing would be like, that surface tension where, remember when you keep two plates, the liquid level rises because of surface tension. This is a epsilon v square by 2d into k minus 1 is equal to, this will be rho, density will be a h d into g. This is how it would look. This would be d, this would be a, and this would be h. You get a cuboid. So that mg. Done. So all this will get h ka value. Clear? That would be a straightforward question. So now you can frame questions based on that force ka part. So if you introduce a dielectric slab, you'll get the force. If you get the force, you'll get the acceleration. So this is what you can do now. Adrat, see, this is what you're asking. So x ka value half AT square hoga. आ गया ना x का value. So you can substitute now. Here you got C equivalent in terms of x, you got energy in terms of x. So what is charge? Q is equal to CV. Oh yeah, substitute. You want rate of change of charge, differentiate. You're only seeing rate of change, matlab differentiate indirectly. That will give you velocity. And what is velocity? A into T. V is U plus AT. Clear? Have a look at this. So questions will be like this, straightforward questions on this. That's the force on a dielectric slab. Next thing. So that is the last model in capacitors actually. With that, we're done with capacitors. So do check it out. The next thing, current.
The next week के test में capacitors डाल दो ना.
Next week test में, it is there.
You put electrostatics, so just can you like put capacitors also?
Capacitor also.
I'll send you a practice paper. Na kar lena kar pe, not an issue.
Okay, that's also.
I'll post it in the group. Normally we give 1 week gap and do it na, so इसलिए नहीं रखा है guess मैंने.
Yeah,
I know
but
your
like
major
if
test
these-
is coming.
yeah,
I
yeah.
know.
So can
I'll
you
post a paper.
put like a practice test on your platform?
Which test you want?
So like on capacitors, like an optional one.
I'll post it in the group ना रे लिख लेना paper just PDF लेके problem क्या है ना the moment I keep one more practice paper I know what you guys did last time there were two papers people wrote some of them wrote this paper some of them wrote this paper and then people started crying sir my result is not there so that is the thing I'll send you the paper in the group you can try anyways next thing current electricity this is actually yeah except the circuits part this is completely different thing a pretty high weightage chapter so let's start it off we'll just start off with the intro so current we will use the symbol I straightforward definition rate of flow of charge the direction of flow of positive charge is taken as direction of current. That means if you have a positive charge going this way and if you have a negative charge going this way, then we will say current is going here, but here we will say current is going in the opposite direction. So be careful with the convention. So I is equal to dq by dt. Delta q is equal to integral I dt. The average current is change in charge by time. That means if you plot an IT graph or if you plot a QT graph, this would be the positive area. This would be the negative area. So the area under IT graph gives you the charge flow. Similarly, here in a QT graph, the slope is dq by dt. This gives you current. And be careful, current is not a vector quantity. It has direction and magnitude but does not obey vector laws. Meaning if you take 5 ampere like this and 5 ampere like this, technically you should get 0 amperes, but you get 10. So it doesn't obey vector laws of addition. That's straightforward. Simple definition. I is dq by dt. That is the main one. Let's see a few questions based on this. Yeah.
We can't write anything, right? Neither scalar nor vector.
So tensor, matlab it behaves like tensor at least for our sake. 11th and 12th में it behaves like a scalar. Clear everyone?
Yes, sir.
Let's see a question based on this. An electron moves in the nth orbit of an hydrogen-like atom. Right? And the average current I is proportional to n to the power of x. N is the principal quantum number, meaning first orbit, second orbit, and so on. Find x. I hope you guys studied atomic structure. They taught you, right? Yeah. So electron going in an orbit is as good as a current flowing in that. So that average current is proportional to n power x, where n is the principal quantum number. Then what is x? Let's see. First of all, if you have a circle of radius r, and if you have a charge q, which is going with speed u, the current I is q by time. Basically, it is the time in which the charge comes back to the same place. It keeps on crossing that position there. So this is q, and time taken is 2 pi r by u. So this is qu by 2 pi r. So current is proportional to speed by radius. Now you should know this. The speed v is equal to v naught into z by n. Remember? The velocity of an electron in the orbit is given by v naught z by n. This comes from atomic structure. And what about the radius? R is equal to that 0.53 angstroms into the value B. I don't know whether you remember or not. 2.16 into 10 power 6. अभी याद आया. In meter per second. 1.8 है क्या? ठीक है 1.8. And then this thing is z by n. और ये कितना था? 0.53 angstroms, n square by z square, right? Z, I guess.
Yeah, only Z.
Only z. Energy में आएगा z square. ठीक है, something like this. Oh yeah, anyway, we are interested only in z भी नहीं है. I could have asked you z also. So u is proportional to 1 by n and r is proportional to n square. So I is proportional to n power minus 3. Clear? So x is 3. X is minus 3. Thus, simple thing, but you should know it's a pretty good one. Then they'll ask you, if this electron is going in a circle, it produces a magnetic field. The magnetic field at the center is proportional to n power what? You can make a pretty good matrix matching based on this. Clear? Makes sense? So main thing, you should know these proportionalities, nahi to you'll be stuck. Current, electricity, you can combine a little modern physics. Next thing, we have a ring here. Lambda, linear charge density. This is rotating with omega, and this is R. Find current. So it's a charged ring rotating with omega to find the current. This is a proton beam. So we have charged particles here. This is going with speed v. N is the number of protons per unit volume. Find current. Yeah, you can say that. What can we do? We can do the same thing, total charge by total time, or you could do like this also. Take a small piece d theta. So this would be r d theta. So dq will be lambda r d theta. Current will be dq by dt. So in this case, the average also will be instantaneous current. This will be lambda r d theta by dt is d omega. So this thing will literally feel like a current ring only. In the previous case, what happened here? This thing is like there's a current, there's no current for some time. So current is coming and going, current is coming and going. So this is like a discontinuous thing. But the second case is not like that. You'll feel as if there's a literally current is flowing continuously. Or you could have simply taken I is equal to total charge lambda into 2 pi r by time will be 2 pi by omega. Same thing you will get. Third one. We have a proton beam which is going with speed v. This is important. This is important. Remember the result. You want to need this later on. NEAV. Yeah. This is what we do. Take a thin slice dx. So the dq charge would be the thin slice is n into a dx. That will be the number of protons per unit volume into volume. Will give a number of protons into charge of the protons. So I is equal to dq by t. So that will be NEA dx by dt, which is NEAV. Where n is the number of charged particles per unit volume, A is the area of cross section, E is the charge of the particles, and V is the velocity, speed. Clear? Next one. Got this, everyone? Done the page? So we have a capacitor. Area of the plates is A. Distance is D. Distance is D. Identical capacitors basically. So this is plus Q and this is also plus Q. Then what happened, interestingly, this plate here started going with V1 and this plate here started going with V2. The plate started moving in the other way. Okay, and so the positive plates started moving with V1 and V2 as shown. Negative plates are fixed. Now, if the plates are moving, the distance will change. If the distance changes, capacitance will change. Then the charges will change. Find the current in the ammeter. Let's get this. We did one more question on current, in Gauss law. Remember this thing? This thing is grounded, charge particles coming towards it, find current. So that is one more question. So literally, you're just playing with one definition, I is dq by dt. You just have to get that q from some other chapter. Show you. See, the main idea here is when the upper capacitor got distance changes, this becomes d plus v1t. So this capacitance C is nothing but A epsilon by d plus v1t, because this thing is going away. This is v2. So the distance will be d minus v2t. So this capacitance will be C2, which is A epsilon by d minus v2t. So the whole question has become simply like, you kept two capacitors. Let this charge be Q. This guy will become Q minus Q, and this will become Q plus Q. This we did last class. And this capacitance is C1, and this capacitance is C2. So Q minus Q by C1 is equal to Q plus Q by C2. From there we can find Q ka value. This would be C2 minus C1 by C2 plus C1. What is current? dq by dt. Substitute and differentiate. I will leave it to you. Clear? That's it. So the whole thing is capacitance only. There's nothing there. Clear? Let's see one more.
So I can show the previous slide.
Clear? Next thing. We have 3 plates here. This is an ammeter. This distance is d. This distance is 2d. The charges are plus q, minus 2q, and 3q. And this guy in the middle started oscillating where x is equal to a sine omega t. Middle plate does SHM. Find the current. How do you do this? Gauss law, current, electricity. How would we start? First, do you guys remember how to distribute the charge?
Yes.
So this guy will become 2d minus x. I'm assuming it is going to the right, and this will become d plus x. So the charge outside will be total by 2. Total is how much? 4q minus 2q. So q. Then this would be q1. This would be q2 minus q2 minus q1. So we know q1 into d plus x is equal to q2 into 2d minus x. And we know q1 plus q2 is minus 2q. So from there we can find q1 ka value and q2 ka value. It'll be a little lengthy, you can figure it out. Now, if you look at this plate here, you're saying this is a current I. So here I is nothing but rate of change of charge on this plate, which is q minus q2. So whatever charge changes in the plate, that is because of this current coming inside only, right? Luckily here capital Q is constant. So I would be simply minus dq2 by dt. Done. Substitute, you'll get the answer. Is the process clear? I mean, I could have made the question simple by saying x is equal to, vt. It's going with constant velocity. That would be more easy. So when it is oscillating in SHM, the current is also flowing in and out. That's also oscillating in SHM. You'll get an alternating current. So that's how you can create an alternating current from a DC things, constant charges. Make sense? You'll be able to handle. So this is one equation, this is the second equation. From there, get Q2, differentiate, you'll get the current. This only, meaning in all the questions, right? Somehow you'll find the charge Q and from there you'll just figure it out.
So I didn't get how you write I is equal to d of q minus q2 by dt.
What do you think we should write?
No, I didn't get how you अब वो आया कैसे मतलब
Okay. What is current का definition?
flow of charge, rate of flow of charge.
Okay, उसको क्या बोलते हैं mathematically?
How much charge is flowing per time dq by dt.
Q क्या था? The
How
rate
much
at which
ever
the
charge
charge is
flowing.
changing. So when this
Hmm.
current flows, what charge changes?
Minus the entire charge will change, but
So वो
minus
क्या था
q2
ये?
will change. So we can also express the same thing in terms of minus q1 also, no?
हाँ, कर सकते हो. In that case, you'll put a minus sign. You want to write like that, then you will say I is equal to minus dq minus q1. Because it is losing, na? Current is going away, so charge should decrease.
Okay, so got it.
That's what you wanted to say.
No, I was just
No.
confused why we won't take both the components in consideration at once.
नहीं चाहिए. Any one will take care, right? See, you
Yes,
have
fair,
200
fair.
rupees, I have 200 rupees. I took 100 rupees from you, right? So do I need to, so if I ask you how much I gained 100, do I need to talk about you? I know you lost the same amount. Both are independent variables, nahi hai. Both are dependent on each other. The moment you got Q2, Q1 takes care of it. Whatever Q1 increases, Q2 increases, Q1 will lose the same thing.
Yes, sir.
ठीक है? And यहाँ पे Q1, Q2 negatives में आएगा. Getting it? Say I took Q1, Q2 positive for a negative plate, so science will take care of it. Is this
Yes.
clear why we had to put a minus sign here? Because charge is leaving the plate. Negative since charge leaves the first plate. So you can take any one, you'll get the same answer. Current won't change. Take a break, small break, come back by 7:10. We'll have a small break. Let's see next one. So we have a capacitor. We have a battery here. So we have a dielectric slab K, whose length is also L. So these are square plates of side L. Distance between them is D. This plate is entering with a speed U. We have an ammeter here. Find the current in the ammeter. Plot current versus time graph. वो better है. Let's get this. Again, if you see it is just a capacitor problem. So that dq by dt looks very innocent. You can literally bring everything. Try. Siner got irritated with current. Differentiate. Let's go. Capacitors is over, people. So try to do finish off solving, whatever is related to capacitors, whatever you're solving, try to finish by next week. Again, I'm telling you, whatever chapters we're doing, whatever chapter gets over within next 1 week, try to finish off the solving part. Don't delay too much. Because if you wait for 2 weeks, then you open this thing, everything will start looking new. You will actually waste more time in revising. Try to do it parallelly immediately. Let's get this. Epsilon C. This thing actually just made it. This is the last problem in the thing. So this part of this thing is filled with a capacitance. So this was X and this was L minus X. Both of them are in parallel. This is the force on a dielectrics level of formula. That is not what I'm interested in. There's a small trap here. So here we will end up with C equivalent, and that guy would be X into L into K epsilon by D plus L into L minus X into epsilon by D. So charge Q would be C equivalent into V. L epsilon by D Kx. So that is X into K minus 1 plus L. So current I would be dq by dt, which turns out to be constant. That is the trap. That would be L epsilon K minus 1 by D. So you get a constant current. But the problem here is
फिर U आएगा ना
plot UB आएगा,
V भी आएगा ना?
VB आएगा.
V भी आएगा ना
So the catch here is when this is entering inside, the charge flows from the battery. So current is positive. This is still L by U. Then current is constant, but it is negative till 2U by U, 2L by U. Are you getting this? When the capacitor mein dielectric is entering, capacitance will increase from 0 to L by U. Na? Once it has completely entered, the capacitor start going outside. So charge will decrease again. So current is coming out of the battery and current is going into the battery. So the current ka direction will change, meaning it looks like this thing, say. So when the slab is here and entering, the current will flow like this. It comes out of the battery. So charge is increasing. This is for time less than L by U. Now, if you wait for enough time, this thing starts getting out of the capacitor. So the situation becomes like this, isn't it? This is for time between 2L by U and L by U. In this scenario, charge decreases. The current will go back into the battery. So current actually reverses sign. Clear? So current is actually not constant. Current will come out like a step function. So for some time, the current will be constant but positive, and then negative and constant. Is this making sense? So if they ask you this question, current is constant, it is the wrong answer. Current changes sign. Current ka magnitude is constant.
So when
So
like
current
it gets reversed, what's happening? Like, is the battery getting discharged or something?
क्या तू भी बता ना, if current goes into the battery, it is getting discharged.
No, I don't know.
Think na, what will it be? Exam mein who will come and tell you? I won't be there. You tell me, if you send current into the battery, what do we call it? That is how you charge your phone record.
Okay.
Current comes out of the battery, it is discharging. Current goes into the battery, battery is charging. You do that every day, at least 2 times per day. You charge and discharge your phones. Next thing. So when the capacitor is entering, the battery is discharging. When it goes outside, the battery is discharged. Okay? Next one. That's the whole concept of charging, meaning you generate a voltage more than the battery, it will get charged up. But anyway, here there is no resistor and all. So a bit of a theory. Drift velocity of electrons. in a conductor. We had a discussion like this a bit in KTG. Let's see again. So if you take a conductor without any electric field, the electrons, right, they move in random directions. So electrons are simply going in random directions. And if you look at the path of any one particle, any one electron, so it's like it's a net average velocity is 0. Basically, this happens due to collisions between them. So average velocity is 0 because the net displacement is 0. We also call this thing as Brownian motion. And if you want to find this thing, we know from KTG, kinetic energy is 3/2 kT, K is Boltzmann constant. This is half into mass of electron into V square. These are called thermal speeds because this is coming due to the temperature, and this is called thermal kinetic energy. If you substitute the values here, this V thermal comes to around 10 power 5 to 10 power 6 meters per second. So electrons do go pretty fast inside the conductor. But the problem, even though they go so fast, the net displacement is 0. So these things are not responsible for any current. So if you just put a conductor, even the electrons are moving inside, you don't get any field. Clear? The same thing happens with the gas molecules also. If you take a container and if you see gas molecules, they behave exactly same. But gas molecules ka mass is little more, the speed will be in the range of 10 power 3, 10 power 4 meters per second. Electrons are too small, so they're just pretty fast. Then the same thing, if you put a conductor and if you introduce a battery now, let's say this is voltage V and this is L. Now this will establish a electric field inside, and because of which we get electrons will start going this way, which is E into E. Now the electrons will start experiencing a force because of this. So here the field will be V by L. Now if you try to look at the electron ka path, there are two things happening. You have a combination of both random and systematic energy. I hope you remember that word, systematic kinetic energy. So this electron is going like this, then take the field as E here. Then the field will pull you here. Then again, the random thing will take it here, but the field will pull you forward. Then the random will take you somewhere here, but the field will pull you here. You can see what is happening. So basically the net displacement is only due to that systematic motion. So we get, it's a combination of random plus systematic motion. This random motion is due to thermal kinetic energy. The systematic motion is due to the battery. And you can clearly see here the net electron ka motion, right? The net displacement is only due to the systematic motion. Is this clear? Do you remember this thing? I told you that example of, that Ganpati Visarjan. Same thing. It is like think of like this. Let's say when you take this, Lord Ganesha for this Visarjan thing, and if you see people around, right, people are just jumping, dancing, they're shouting, they're doing any nonsense. You can't predict what that person is doing. But we know the movement of the procession, the statue goes from here to here, that randomness also goes with the statue. So we have a random motion which is systematically moving. You can predict the path of that procession. You can tell you at what time the procession will reach here, everything. But you can't tell what this one single person is doing around the statue. So that is a beautiful combination of a random motion which is moving systematically. So something similar happens here. So no matter how much this person jumps around here, the procession doesn't move. He will be there with the statue only. Only when the statue moves, the procession will go forward. So the randomness will keep moving. Something similar you're noticing here. The battery is like a systematic procession. Arams, it is dragging you, and the random motion is just moving around. So no matter how fast you go, thermal kinetic energy, you're not responsible for current. Then, now, if you get into little calculation part of this, so let the field be E. So the electron will have this thing. So acceleration will be E by m. And we know field E is equal to V by L. So we define something called V drift is nothing but displacement by time, average basically. So displacement will be half A tau square by tau. So tau is called relaxation time. This we studied in KTG if you remember, mean free path by this thing. So this is your average time interval between two collisions. If you remember, tau is given by free mean path by V mean or V thermal in this case. So here you can clearly see if temperature increases, V thermal increases, and therefore tau decreases. Basically, they'll start colliding more and more. So this thing comes out to be A tau by 2. So what you got here is these electrons are, our arms are moving here with a speed here. We call them V drift. And this V drift is in the range of 0.1 to 1 centimeter per second. They're just too slow. And we know from that problem I is equal to NEA V drift. This is the problem 1C. So there we got this current in terms of drift. Have a look at this. We'll substitute this in the next page. Clear? Remember what is relaxation time? KTG में last thing that we did. Relaxation time, free mean path. Free mean path का formula याद है? What is the formula? 1 by root 2 pi. Then what do you get? Number of moles into gas constant by current into voltage by viscosity. What is the formula? Root pi sigma square eta v rho or nv or number of molecules by volume. Sigma is the diameter and by v is the number of molecules by volume. Don't forget records. So we got I is equal to NEA V drift. So this is NEA and V drift is A tau by 2. So NEA and A is how much? A is EE by M. And E is V by L. Where are we going ahead with this? You'll see something interesting. You will notice you'll get V is equal to I into 2M by N E square tau L by A. This quantity is V is equal to IR. This is your Ohm's law. Basically, we proved Ohm's law, where that quantity we defined rho resistivity is 2M by N E square tau. Then we defined resistance is rho L by area. And that's your Ohm's law. So all that story that we did is to prove this thing. So we have some important points here. If you increase the temperature for conductors, when temperature increases, tau decreases. Basically, the more collisions will happen. Therefore, rho increases. And therefore, resistance increases. So for a conductor, when you increase the temperature, resistance increases. But semiconductors, something else happens. The semiconductors also tau decreases, but when temperature increases, they have a less free electrons. Most of the electrons are trapped in the atom. So more free electrons are released. So basically that dominates, that N ka value dominates even though the tau decreases. And N increases, there's a density. Therefore, resistance decreases. So be careful for conductors, semiconductors, with increase in temperature, it is different. We did something like this before. Remember which chapter? Some property increases, some property decreases for something. ऐसा कुछ था.
Then what do you mean by more free electrons are released? मतलब क्यों?
ये N क्या था? Number of electrons per unit volume ना?
Yeah, right.
In a conductor, you have a lot of free electrons. In a semiconductor, you have less free electrons.
Okay.
What are free
अच्छा,
electrons? Electrons which can
हाँ,
come out of the atom and roam around, isn't it? So sodium में, if you see that last electron 3s1, that is ready to come out any day. But if you take carbon, that electron doesn't want to come out only. Energy देना पड़ेगा उसको. So those times, that's the reason carbon is almost a semiconductor insulator. Same thing with silicon. R decreases. You saw something like this before in some other chapter. When you increase the temperature, it increases for something and decreases for something. What property is that? याद है? What? Drunkards. सब लोग गजनी बन गए यहाँ पे. Viscosity. When you increase the temperature, viscosity of liquids decrease, whereas viscosity of gases increase. Two people remember. Surface tension नहीं है रे.
अरे सर ये सब बोर्ड्स में आता है ना.
हाँ, बोर्ड्स में आता है, मेंस में आता है, बिट्स में आता है, and then after that you come and tell me, oh sir, इतना simple question I left it uncome. You know, then you'll cry next day, sir, bits पुरानी CS miss हो गया, sir, bits गोवा में आया, sir, मैं क्या करूँ? That 4 marks only will goof up everything. That 4 marks can put you in IIT Bombay or IIT Gandhinagar. कुछ difference नहीं है, सिर्फ 10 घंटा है. They do ask करे even in mains. चल एडवांस में नहीं पूछेंगे, बिट्स में तो आएगा. Clear with this? even an advanced, you know how they'll ask you? They'll put this in a more than one choice question by one of the statement, and they'll give you the reason also. So we can take resistance, right? Like this. So R is equal to R naught into 1 plus alpha delta T. It just looks like that. Here, alpha is the coefficient of resistivity. R naught is the resistance at 0 degrees. Clear? So let me just brief it up a bit. So when we say Ohm's law, now understand everything doesn't obey Ohm's law. Ohm's law is I proportional to V. Yeah? V is equal to IR is not Ohm's law. I is proportional to V. Because of the voltage, current comes. This is the Ohm's law thing. And then if you see materials which obey Ohm's law are called ohmic conductors. So everything doesn't obey Ohm's law. So if you have a VI, so here basically dV by DI is a resistance. But sometimes, right, you can have a situation where something like this is also there. So current is not increasing linearly. So we have something dV by DI, it's called dynamic resistance. So even this is valid. You have a resistance which is changing with current. The resistance is not constant. And here when you write this R is equal to rho L by A, this we did discuss in heat transfer. L is the length along the current flow. So be careful, you cannot take any length you want. So that is the reason battery cut terminals would matter. A is the area perpendicular to the current flow. Clear? Going ahead. Then we define something called current density. The symbol is J. So even though current is not a vector, current density is a vector. So current density is simply current per unit perpendicular cross-sectional area. So current per unit perpendicular area. Example, let's say if you take a cross-section like this. This is I. The area vector will be perpendicular to this. J bar will be like this and this is theta. So we have current I is J bar dot A bar. So J bar has the same direction as the current flow. So J bar is in the direction of I bar. in the direction of current. Current is not a vector. So this will be JA cos theta, where theta is the angle between area vector and this thing. This is current density, current per unit area. Quite a useful thing, especially in magnetism, we will use this more than here. I wanted to add something here. Here, see, alpha is positive for conductors, means resistance will increase. Alpha is negative for semiconductors. Clear with current density? Now, if you talk a little about that rho and stuff, rho resistivity, I won't expect you to remember this, but at least you should have an idea about this. 2m by ne square tau. In this, right, they can play around. So, example, they can ask a question like this. In an hypothetical atom, right, the charge of an electron is tripled. And mass is doubled. Then what will happen to rho? What will happen to the resistance of the circuit? You can clearly see rho is proportional to m by e square. So the new rho will be 2 by 9 rho old. That means in this thing, the new resistance will be 2 by 9 or old. They can ask you like this. They can mess up the whole question only. They will say, in an electrolyte solution, the ions are flowing instead of electrons. The ions are flowing. The ion ka charge is, let's say it is a maybe Mg2 plus ion. So basically, M ka place mein you have to use Mg ka mass, magnesium ka, and charge ka place mein you have to use 2e. So that's the current due to the ions. So you can play like that also, right? Or they can ask you even like this also. Find the error and resistivity. They say during a measurement it is observed the electron ka mass mein there's a small error of 0.01% and charge mein there is an error. So they can play with errors also. So d rho by rho is dm by m plus 2 de by e. So for that sake, they never asked anything like this, but they can always poke around. So you should know. So we also write something called sigma, which is 1 by rho, which is conductivity. The reverse of resistivity is conductivity.
So in that magnesium question, like we'll assume in an relaxation time to be the same or what?
वो भी change होगा. They need to give more information.
So they'll give that in the question.
They'll give, matlab, they will say something more.
Okay.
So here I'm assuming, everything else is same. And then when you relate them, you end up with J is equal to sigma E bar. This is the relation between current density and field. So these are quite important results. This one, so this you can derive from that V is equal to IR thing. This one, basically this guy. This is anyway there. Be careful, they'll ask you which of the following is an Ohm's law. V is equal to IR is a blunder. I is proportional to V. And then all this stuff. Clear?
Sigma is conductivity, right?
Conductivity. Clear, everyone? Now here we have some theoretical discussions actually. First one, is this. If V drift is like so slow, right? And let's say we have a bulb here, and when you have a battery here, and you're saying these electrons are moving with like what, 1 centimeter per second, shouldn't there be a delay? If V drift is very less, right? The electrons will take time to reach the bulb or the whatever is the source we are using. Then why does the bulb glow immediately when you switch it on? Because you said the thermal velocity is not responsible for any motion. Drift velocity is 1 centimeter per second. If you look at your switch and bulb, that is almost 3 to 4 meters ka distance. So technically speaking, after switching on, it should take 300 to 400 seconds for the bulb to glow because the electrons will take so much time. Then the question is, why does the bulb immediately glow? What do you guys think? Making sense what I'm asking? Because you said V drift is responsible for current.
The electrons are already there. They just are moved by the.
Bulbs और capacitors, ignore capacitor ना तो क्वेश्चन चेंज मत कर, जो पूछा उसका आंसर कर.
So does
Pushes
heat
electrons
flow
with
faster than
electron.
current?
Saina says drift velocity pushes electrons, which pushes other electron. That means it became a wave, na re? So think about it. If you're standing in a queue, if you push this guy, immediately will this guy move? Takes time, isn't it? So basically, you created a wave. So even then, there should be a delay. Adrit, you're saying something?
So like, does the heat flow faster than this thing? Like heat
Heat,
produced
तो
in one
चुप
area?
रहो, तो क्वेश्चन चेंज मत कर.
अरे,
हीट कहाँ से आया रे? मैं पूछा करंट
the
हीट.
bulb works like this only, na? Like an incandescent bulb due to the heat.
मतलब अगर according to तेरा लॉजिक, अगर रेफ्रिजरेटर यूज किया तो इलेक्ट्रॉन्स मूव ही नहीं करेगा बिकॉज वो कोल्ड है अंदर.
नहीं, अरे, heating effect of current and then the bulb starts lighting up, na? The filament.
Arey, see, Arjun, electron will move, then there'll be heat produced, isn't it? You're talking as if because of heat the electrons are moving. You're
No,
getting
I'm
heat
saying
because the electrons are
the
moving.
heat produced by the electrons moving, that
Okay.
reaches before the electrons reach there. That's what I'm trying to say.
The electrons are already there in the wire. The battery is
Okay.
Yeah.
them moving.
And then the
The
heat is
electrons near
produced.
the bulb are moving.
So, what they're saying, na, see, I know they got that, but words nahi aa rahe. When you switch on the battery, na, what we are thinking electrons are moving. It's not like that. The electric field is established in the entire wire instantaneously. It's like a conveyor belt. Remember I told you? It's like already all electrons are sitting here. The moment you switch on the battery, it is like you're moving a conveyor belt. Everyone starts moving at the same time. Agreed, this electron will take time to reach there. The electric field is established in the entire circuit at the same time. Meaning that travels with the speed of light almost. The circuit very fast. There is a delay, but it happens very fast. So all electrons start moving at the same time, like a conveyor belt. That would be a better analogy than saying, like, you're pushing, I'm pushing you, you're pushing, and all. It's like everyone starts going at the same time. All electrons move at the same time. Think of a conveyor belt. That would be a better example. The battery is simply the motor which is running that belt. So aisa hai na? So when you're standing at some point, the belt ka link is not coming to your place, right? The reason you're moving is because the whole belt is moving at the same time. So this is one. Second argument is this thing. Remember in Gauss law we said field inside a conductor is 0. But here you're saying there's a field suddenly. Here there's a field inside the conductor which is moving the electrons. What are the catch? Anyone? That is because I didn't write the full statement. We said field inside a conductor is 0 due to static charge distributions. Here there's no static charges. Battery is a thing which is continuously pushing you around. Basically, the system is trying to reach an equilibrium, but the battery is continuously disturbing you. Now, if you think about that example, that room wale thing, let's say there are 2 rooms. Now I came here, right? I'm pushing people from here to here, but unfortunately, there is one more secret door from this room to this room. What will happen? Every time I push people, they'll simply come back here. I'll push people, they'll simply come back here. Every time I'm trying to imbalance the room, they're coming back again. So the system will never reach a steady state. You're getting it? So a battery will create an external field there, which is always disturbing the field. So system will never be in equilibrium. So here basically system never reaches steady state. The electrons keep moving. So current flowing in a circuit is actually meaning the charges will never come to rest. Everyone will eventually acquire a constant velocity, steady state, but they will never be at rest. Field and system never gets a chance to induce charges, or you can say the system kind of, they all reach a constant velocity. So the main word is this, due to static charge distributions. Here there are no static charge distributions. So field inside a conductor can be there. So that is few things about this thing. So next class when we catch up, we will do problems based on this. And then we will have problems based on all these things that we did today. And then we'll go ahead with circuits. So tomorrow, next class, we will be doing circuits also. Circuits, most of them we did. So we will do some other little new different ones. And maybe we'll see some symmetrical circuits and everything stuff. Okay, so with that, we'll wrap up for the day. So do start solving capacitors, do finish it off, whatever you're solving. Right, booklet or whatever you're solving, do finish it off. Don't take too much time, take a week and try to finish by at least next Wednesday.
So you'll be covering electrical instruments also here only, right?
Yeah. Sabhi yahi pe hoga. Okay, with that, we'll wrap up for the day. So any doubts, anything, stay back and ask. Also free to leave. So take care, stay safe. I'll see you.